Hello everyone, welcome back. So today we will discuss about Doppler's effect. So this effect is a modification of frequency. Modification of frequency means suppose any source that is producing the sound and it is approaching towards you, towards the observer or the detector. At that time we get a modified frequency. We generally get the frequency that is more than the produced frequency, and similarly if the your source is moving away from the observer or the detector, then we get the less frequency than the originally produced frequency. So how this frequency modified, this was studied and explained by an Australian physicist, Doppler, so in 1842. And this effect is named after him, and that is Doppler effect. So here we'll find out, or we'll discuss about basically three cases, and finally we'll generalize these three cases into one formula so that it will be helpful to your in your examinations, and also this generalized formula also it will be easy for you to remember. So when we'll discuss all the three formulas, three cases, then at last we will discuss about the generalized formula. So watch till the end. So the three cases that I am saying is, one is your object, or you can say your observer is at rest, source is moving. Source can move either away from the observer or towards the observer. Now this Doppler effect is applicable both for sound waves and for other electromagnetic waves also. So here in this case basically we will restrict our discussion for sound waves only. You know, sound wave produce compression and rarefaction, and it is a longitudinal wave. So let's say an source, let's say any ambulance or any other car, or your you can say train, it is producing some sound and it is approaching towards a detector, or it is going away from the detector. So in that case your frequency will be modified. So this will be the first case, whether the observer or your detector is at rest. So I'm in short form I'm writing, that is detector stationary or rest, observe your source moving. Source means the one which produce the sound is source. So source moving. Source moving means it can move either away or it can move towards the detector. So this will be the first case. Second case will be the detector moving towards the source, or it can go away from the source also. So source is producing the sound continuously and the source is at stationary, the detector is moving. So detector moving, detector or observer, so detector moving, source at rest. So these are the two cases. Now the third cases, maybe both are moving. If both moving with different speed, right? So let us discuss these three cases one by one. The first case is detector at rest, source moving. So let us discuss the first case. So source is moving, let's say the source is moving away from the detector. Here is your detector, let's say D, right? And this is your source, which is producing longitudinal sound wave, let's say. So compression, rarefaction, it is producing the sound and produce the first, let's say, first pulse or first compression here. Now let's say the initial distance between this source and the detector is, let's say, L. So the source is moving, right? and it will produce the next pulse, let's say after the time period t0, because one compression, then rarefaction will come, then again compression. So compression to compression, the time period, one complete wave means one time period. So let's say next compression comes up here, one compression comes, first compression, then second compression comes up after the time period t0, and this is your source is moving to the right, let's say with a speed vs. So what will be the distance? The distance will be Vs T0. How much distance it will cover in this time period T0? Vs T0 will be the time distance it will cover. Now initial distance is L. So when the source will produce the first pulse, how much time it will take to reach the detector? Detector is at rest, first case. So detector rest, D rest, S moving, right? So the first case, the time t1 it will take for the pulse to reach detector is distance upon speed. Speed is the speed of the wave, the sound it is produced. Basically the speed of sound in, if it is the medium is air, it will be, let's say 330 approximately meter per second. So this is your V. Don't confuse with V and Vs. Vs is the source moving. Suppose your one ambulance is producing the sound, ambulance is moving ahead, this is the speed of the ambulance, let's say Vs, and detector is at rest. So the first pulse, it will take time t1 and it will be L by D. The second pulse this detector will receive after the time period t0, and this after the time t0 this source will produce the your pulse. So this pulse will travel how much distance? Now it will travel some extra distance, this one. So total distance it will travel L plus Vs T0. This much of distance it will travel, and this much of distance it will travel with a speed V plus extra time period t0 it has traveled here. So the total distance, total time it will take t0 it will take, because the second pulse will come up after time t0, then the second pulse will travel also this much of distance. Then this much of distance is L plus Vs t0 divided by your, this is your distance and this is your speed. So this is the time t2. Now the interval, the t2 minus t1 will give you the interval that the detector is getting first wave at time t1, second wave it is getting t2. So for the detector, the time period will be, the source is producing the waves after each t0, that means time period is t0, right? But the detector is getting the wave t2 minus t1, that is the time period for the detector. So we'll find out t2 minus t1, that will be the time period for the detector. So that will be the t for the detector basically. So just we'll subtract it, t0 plus L plus Vs t0 by V minus L by, this is L by V minus L by V. So you can simplify this one, right, easily. So this is t0 plus L by V plus Vs t0 by V minus L by V. L by V cancelled out, t0 you can take common. So t0 you will take common, 1 plus Vs by V. This is your time period, modified time period. This is the time period for the detector. This detector will get this time period, this one, t0 multiplied. So in terms of frequency, if you want to write, because we are interested to find out the modified frequency when the source is moving away from the detector. So in terms of frequency, if you want to write, frequency is 1 upon time period. You know that f equal to 1 upon t. Some books use nu, but we get confused with velocities or speed v. That's why I'm using f for the frequency. So f is 1 upon t. So here if you want to convert it in terms of frequency, this will be 1 upon t0. That means the original frequency produced by the source, and this is your, this is the 1 upon t, that is the frequency that the detector will get or the observer will get. So it will be f0, and the reciprocal of this one, reciprocal of this one means you just find out the value. The LCM is V plus Vs. So you will find the reciprocal, that will be V by V plus Vs. So this is the frequency when the detector is moving away. When the detector will come towards, then you will just replace your source velocity as negative because the direction is changing. So source velocity speed of the source will change the direction. So we will, instead of positive, we'll just use a negative sign in the numerical, so that we'll get a modified one. Now see, denominator V plus Vs. So if Vs will be more, if in the denominator we are getting Vs, that we are adding with V. So when the source is moving away, basically you are getting plus. That means denominator is more. That denominator more means your frequency, that the modified frequency will be less. That means when the you are standing, your, let's say your ear is the detector and the ambulance is moving away from you, so you will get a less frequency than the original sound, that is original frequency produced by the ambulance, right? The sound of original frequency, you will listen a lesser, right? The frequency will be less than the original sound. Now if same ambulance will approach to you, then you will get V minus Vs. That means denominator will reduce, so denominator will be less, means you are getting a more frequency. Your frequency that you are listening will be more than the frequency produced or the sound produced by the ambulance or the source, right? So this is the first case we have discussed, that is detector rest and source moving. The second case is detector moving, source is at rest. The source is at rest, it is producing the continuously from one position, continuously it is producing the wave or the sound wave. Now this is your detector D, this is your source. Now as detector is moving, so here one relative velocity concept you can say, because the sound wave which is produced by the source is moving with a speed V, and detector is moving, let's say, with a speed VO or VD. You can write observe, you can write VD. It is moving with a speed VD, or observer if you are writing, so you can write V0 also. So then as both are approaching each other, so there will be the speed will be added with each other, so there will be relative velocity. So the first pulse will reach, because it is moving ahead, so relative velocity will use. So the first pulse will get the detector will receive by it will take the time, let's say the distance is x or L, whatever you will use, L by V plus Vd, V L by V plus Vd. Now let's say when it will produce the second pulse number 2, at that time the detector is, let's say, at a new position. So the new position will be at a distance, your T2 will be equal to your T0, because it is producing the next pulse after T0. So of course T0 plus the distance by speed. Distance is now new distance, that is here, let's say D prime. So D prime S is the new distance. So new distance will be L is the total one. So L minus the speed of this your detector. So Vd your T0, in time T0 whatever it has moved. So the net distance is L minus Vd. Vd is the speed of the detector, and it has moved suppose this much of distance in time, so T0 by same, because it is approaching V plus Vd, whatever the denominator here, it will be same, that is V plus Vd. Now the difference is what your observer or the detector will get, the time period, that will be the time period for the detector. So T2 minus T1 is equal to T, time period for the detector. So which will be equal to, just subtract it. So that, see, L upon V plus Vd, here also L plus V upon Vd. So this term will be cancelled out, I am writing directly. So T0 and this term will be there, minus Vd T0 by V plus Vd, or you can take common T, that will be 1 minus T0 V plus Vd. This is Vd. T0 I have taken common, 1 minus Vd upon V plus Vd. Now this one you can take common. This one is the LCM is V plus Vd, so this will be T0 and Vd cancel, so V by V plus Vd. Or if this is your T, so in terms of frequency if you want to write, so it will be the reciprocal, it will be F0 V plus Vd by V. So now see the difference here. So this is case number 2. So here if this detector will approach towards the source, then your frequency will be more because it's in the numerator. And if this one, your detector speed, it will go away, right? If it will move towards, the speed will increase. If it will go away towards the negative axis, you will use a negative sign, so numerator will decrease and your frequency also decrease, right? So this is what we got the second case. Now let us discuss the third case when the both are moving. So both are moving also we'll discuss in a similar way. In a similar way we'll discuss the both moving case, and we'll finally write down the general formula, which is very important for your exams, or to remember this Doppler effect in one formula. So now when both are moving, let's say your detector is also moving and your source is moving, right? Both are moving. Second case was source was at rest, right? So both are moving. So when both are moving, and detector is also moving, source is moving. Let's say the first wave, first pulse, first compression or rarefaction produced by the source, and detector moving towards it. So what will be the time the first pulse will reach the detector? T1 will be of course L by your, and it is approaching, and this B is coming here, so it will be L upon this will be V plus Vd, the first T1, right? Then your T2 will be, now detector will be at a new position, let's say D prime, and your S will be at S prime, and the distance, this time it will take T0. Let's say source is moving with a speed S, Vs, and your detector is moving with a speed Vd. So the distance here will be Vs T0, and this distance will be Vd T0, because in T0 time all this movement happened. So now what will be the new distance? New distance we can write L plus this minus this. So we can write T2 will be of course after T0, so T0 plus, as I told you, this is initially L is the total distance, L is the distance, then it has moved away this one, so this will be Vs T0, then new distance is this one, right? New distance is from here to here, so this is your L, this is your Vs T0, and so L plus Vs T0, and so this one is the extra, so you will subtract it, that is Vd T0 by as it is moving towards, so the pulse is coming here, so we'll write V plus Vd. Now what is the procedure? Same, T2 minus T1 is the modified time period for the observer, so T2 minus T1 will find out directly. I am doing is the time period for the observer, which this L plus V plus L upon V plus Vd, this will be minus L by V plus Bd. So this will be cancelled out. I'm not writing directly. I'm writing directly. So this is T0, and this one is, you can take T0 common. So this will be plus Vs minus Bd by B. This is Vs. This is Vs T0. This is your Vs T0. Vs T0 upon V plus Bd multiplied by T0. So T0, if you will take common, if you will take T0 common, it will be 1 plus V plus Bd. That means V plus Bd, T0 common, so 1 LCM, so we'll multiply V plus Bd minus Bs minus V plus Bd plus Bs minus Bd divided by V plus Bd. So Bd cancelled out, right? So you are getting V plus Bs by V plus Bd. So what you are getting? T0 V plus Bs by V plus Bd. So in terms of frequency, if you want to write, just reciprocal F0, this one will be V plus Bd. This denominator will go up upon V plus Bs. So this is the modified frequency for both observer and detector. If they are moving, so you can write V plus V0 or V plus Bd by V plus Bs. This is the third case when both are moving. Now see, suppose you are sitting inside a train compartment, your train is moving and you are sitting, you are also moving. So when in this case, both you are listening, when the train creates some sound, you are listening to that sound, let's say. So in this case, what happens? The source is train and you are inside the train. That means your detector is your ear, your detector speed and the source speed both are same. So if both are moving with same speed, then what will happen? Vd and Vs will be same. That means this numerator denominator becomes same. It will be cancel out 1. So F equal to F0. That means whatever frequency the train is producing or the sound produced by the train, you will listen, your ear will listen the same frequency. Your ear will not get listen any modified frequency. It will get the same frequency as the train is producing. So this is your F equal to F0 V plus Vd upon V plus Vs. Now the general formula I was talking about, the general formula will be F equal to F0. F equal to F0 will get V plus minus Vd, V plus minus Vd upon V plus minus Vs. So this is your general formula, very important, remember. So you can use this one in any of the problem. Now let's see how can you get the first formula from this. So the first formula, if you remember, we got that for the first formula, what we got? Okay, first formula we got F equal to F0 V upon Vs. This is the first formula we got, right? This is the first formula. Now see, first formula is the detector is at rest and source is moving. The detector is at rest and source is moving. So detector rest means Vd will no speed, detector having no speed, so Vd will leave 0, and source is moving, it will have some speed. So V upon V plus Vs. This is what we got. V upon V plus Vs. Plus minus means plus will use when in suppose this is when the Vs is moving away, right? We will use plus, right? When Vs is approaching, we'll use minus because it should be denominator should less when it is source is approaching, so that you will get more frequency, right? When your source is moving away, then it should be plus b plus bs, because the denominator should be big, so that you will get the less frequency when it is moving away. Fine. So we got the first formula from our generalized formula. Now second, how will you get the second formula? Second formula is this one. Second formula is what? Detector moving, source is not, source is at rest. So source is rest, b is 0, speed of source is 0, so we'll put 0 here. So v plus bd by b. So when source is moving towards, when source is at rest, when the detector, this is source, now detector is moving towards, so detector moving towards the source, right? Your b is 0, then b plus bd, b plus bd. When detector is moving towards, it is approaching, so the numerator should be big, so that you will get a modified frequency and more frequency you should get, right? So v plus bd you will use. So we are getting the first formula, that v plus bd by v f0. Now when you are moving away, the speed should, the frequency should be modified, and the modified frequency must be less when it is detector is moving away. When detector is moving away, you will use v minus bd instead of v plus bd. Your bd direction will change, you will use v minus bd, right? And the final, if both are moving with a two different speed, so you can use v plus bd and v plus vs. This is the final formula, also the third formula you are getting. Now accordingly, suppose the source is moving, the detector is moving away, source is moving forward, detector is moving away, right? So here plus, but detector is moving away, so detector minus, source is going that way, that means detector moving away, so you will use accordingly the signs also will change. So you can take a reference line like plus if it is moving to the if it is moving to the positive axis, right, then we'll use plus. If it is moving towards negative, then we'll use minus. So here b plus bd, that means your source is here, detector moving towards the right side towards the source, so it is, we have used plus, right? So in that way you can use a general idea and sign convention. Always remember, when they will move away, there will be the frequency, modified frequency will be less than the original sound. When they will approach towards each other, then the modified frequency will be more than the produced frequency. So using the general formula and each of the formula, you can solve lots of questions, and many competitive examination the question comes from the Doppler effect. So you should remember at least the general formula, so that you will have an idea and you should know how this formula are derived. Any questions, any doubt, if you have, you can ask in the comment box, so that we can discuss in the next video. Thank you for watching. See you in another video. Bye bye.